In this video, we are going to see what a sampling distribution of mean is and how to describe the sampling distribution of mean using a normal curve and the difference between the shape of just the distribution and its sampling distribution. We know that the normal distribution is a bell-shaped symmetrical curve defined using its mean mu and standard deviation sigma, and the equation of the curve is if x or y equals 1 by square root 2 pi e raised to negative half x minus mu by sigma the whole squared, half of it. Now this normal curve is used in many biological variables, and they describe the population distribution or a probability distribution. We have a family of curves here, and it looks like the shape is the same. The only thing is it is shifted. So the standard deviation are the same. There is no deviation in the spread. The spread is the same, but the center of these curves varies. Because in a bell-shaped curve, the center becomes the mean, so the mean varies and the standard deviation is not. We can learn this using an application here. Let's see this. There are two curves here. When I'm trying to move this, it looks like the standard deviation is not altered, but the mean changes. When I'm moving to the right, the mean increases. And when I move to the left, the mean should decrease. The standard deviation is maintained here. Maybe there is a slight difference because the point is not moved exactly at that same height. So we see that the standard deviation does not change, but the mean increases as the apex is moved to the right and decreases as it is moved to the left. We have a family here where the center is the same, the mean is the same, but the spread varies. It is decreased as it goes to the peak curve. The variation, the standard deviation decreases. So it is different. Maybe for the flat curve, the standard deviation is more 6. The middle one, the standard deviation is 4, and the peak curve, it is 2. We can understand this using a model here. So moving this apps vertically stretches the curve so that it reaches the higher but becomes thinner. This transformation changes the shape of the curve and the shape of the area underneath the curve. The mean does not change as the graph is stretched vertically because the horizontal position of the apex identifies the mean of the density curve. The standard deviation does change because the spread of the curve is changed. As the apex is moved up, the curve becomes thinner and the standard deviation becomes smaller. So the mean does not change, but the standard deviation decreases as the graph is stretched vertically and increases as it is compressed vertically. The sampling distribution is obtained from different random samples taken from the same population, which will give different statistics. A statistics computed from these random sample will also be a random variable. So the sampling distribution of a statistics is a probability distribution of that statistics for samples of a given size n. So if the original population is a normal distribution with mean mu and standard deviation sigma, as we have seen earlier, this sampling distribution, since sampling distribution is a normal distribution with mean mu, standard deviation sigma by square root of n, that curve will be the peak curve. So suppose if we take n is equal to 10, then the standard deviation reduces from the original. So the distribution of the sample mean is less spread than the population. if we are trying to find the distribution for one object or one observation, then it will be the initial curve, the flat curve. If you take a number of samples, say n is equal to 25, that will represent the peak curve. According to the central limit theorem, if n is large and whatever be the population, the sampling distribution will always be approximately normal with the same mean mu, but the standard deviation will be sigma by square root of n. So which will be the curve for a sampling distribution of mean will be the peak curve. So in this distribution, we learnt about the sampling distribution of mean and also the graph between the original distribution and the sampling distribution. Hope this video was helpful. Thank you for listening and thank you for watching.